Section 4.3 Homework 30-T. A professor feels that there is a relation between the number of hours a statistics student studies each week and the student's age. She conducts a survey in which 26 statistics students are asked their age and the number of hours they study statistics each week. She obtains the accompanying results, and we're going to complete parts A through E. The first part is they want us to draw a scatter diagram of the data. So let's go ahead and do that. So we're going to open this data up into StatCrunch. Okay, so we have the explanatory variable, which is the age in X, and the response variable, which is the hour studying. So let's go ahead and create a scatter plot. We're going to go to Graph, select Scatter Plot. Our X variable is age, our Y variable is hour studying. Okay, and then the points are displayed, and then we want to make sure that we select the horizontal and vertical lines. Let's go ahead and select Compute. So there is our scatter plot. Okay, so we know that the age is the horizontal axis and the hour studying is the value here. So let's look at A. We can see that we have these points, but it doesn't have this lower point down here or this point on the top right. So we're going to not include A as part of our answer. Same thing with B. You can see that that point in the upper right hand corner is not part of that graph. Same thing with C. So it looks like it's going to be D. So let's go ahead and answer our question. Okay, now it says determine any potential influential observations and choose the correct answer below. So let's take a look at this scatter plot. Well, are there any potential influential observations? Well, these are all kind of jumped together, but if you look over here and we select that point, you're going to see that the age X is 35 and the hours for Y is 8.1. So therefore, that is an influential point. So it's 35, 8.1, so we're going to select B to be the influential observation. And therefore, there is that. Now it says find the least squares regression line using all the data points. Okay, so we're going to go open this back up in StatCrunch. Okay, and now what we're going to do is we're going to now go to Stat. We're going to select Regression. We're going to go to Simple Linear. We're going to make sure the X variable is the age in X, which is the explanatory variable. The Y variable, which is the response variable, is the hour studying. Okay, and then what we're going to do right now is we're just going to select Compute. Okay, and what we want to do is we want to be able to find the least squares regression line. And it says round the slope to 3 decimal places. So here is our slope. We're going to round it to 3 decimal places. So that 6 is going to make us move that 2 to a 3. So it's going to be 0.233 as our slope. 0.233. And then our y-intercept, it says to round it to 2 decimal places. So rounding that to 2 decimal places is going to be negative 0.94. So negative 0.94. And let's check our result. And there's our answer. Okay. Now it says find the least squares regression line with the data point 35, 8.1 removed. So we're going to come back in here, okay, and then we're going to go ahead and then close this out, and then we're going to find that point and we're going to remove it. So we're going to remove it here. So I'm going to go to select that. I'm going to edit and I'm going to delete that row. Okay. And I'm going to select Compute, and now that is gone, or you can just erase it if you wanted to. Okay, now what I want to do is I can go back and do this again, or I can go back and use what I've already saved, but let's just go ahead and do this again for practice. So I have Regression, Simple Linear. Now I'm going to go ahead and select age again for my X variable, hour studying is my Y variable, and now I'm going to go ahead and select Compute. Okay, now let's take a look at the slope and the y-intercept. Well, again, round the slope to 3 decimal places. So that 6 is going to round that 5 up, so it's going to be 0.156. Okay, and then we want to find the y-intercept. And the y-intercept, they want us to round it to 2 decimal places, so it's going to be 0.61. Okay, now let's check our answer. Okay, so now it says draw each least squares regression line on a scatter diagram obtained in part A and choose the correct graph below. So in this case here, we're going to have to look at both the information that we have. So here, I have my graph, and this was the second graph that I had put together without the influential point. Okay, and then I'm going to open up the other one, which was the second one, and I'm going to go and then select that graph, and then I want to look at both of these graphs. So let me expand this a little bit more so we can see what these graphs look like. So we're not going to be able to graph them on the same plot, but we can at least take a look at that. So imagine if this line is then graphed on this line, and then we want to compare our results. Okay, so here we're going to see that these points with the influential point, this line is going to be a little bit below that, which is going to represent the blue line. So the blue line is going to be the first equation. And so if you notice here, this line is below that line is above, and that line is above that point. So we're going to exclude B and C. Now we're going to look at B and D. So here you're going to notice that this point here, okay, is close to that point. And then our other graph is going to be around here. Okay, so you can see there's a little bit more of a gap between those two lines. So it looks like it's going to be part A as opposed to part D. So let's go ahead and check that. And there's our result. So again, you kind of have to look at both of those graphs at the same time to be able to answer that question. Okay, now in part C it says, use the regression equations in part B and C to comment on the influence that the point 35.8.1 has on the regression line. So I'm going to go ahead and copy the results from B and C so we can compare that. So here, remember, here's the influential point. Now it says find the least, we have the slope. So the slope with this point, okay, was 0.233, and then when it was removed, it was 0.156. So we need to compare that. So the inclusion of that point, okay, in the data set, or the inclusion of 35.8.1, causes a slope of the regression line to increase, because that means that when you're including the point, when it was removed, it was 0.156, and then it increased to 0.233. Okay, so let me go ahead and correct that over here. Okay, so that was 0.233, and the y-intercept, if you notice here, decreased, because it was with the point removed, it was 0.61, and it decreased to negative 0.94. Therefore, the point substantially affects both the slope and the y-intercept of the least squares regression line. So we're going to say that the point substantially affects both the slope and the y-intercept, so the answer is going to be A.